All right, and welcome back. So in this video, we are going to be doing 3 examples that correspond with the worksheet that y'all are working on today. We're going to be going over 3 types of examples, all with solving systems by the substitution method, which is what we've been practicing most recently. So let's have out that worksheet, and let's go through the first example together. Let's go through problem number 1 together. Problem number 1 is the system y is equal to 1 and negative 4x plus 2y is equal to 2. So we want to find the point of intersection as if we were to graph these equations. Now, we aren't going to be graphing. We're going to be using that substitution method. So we're looking at the pure algebra relationship between these two equations. And we want to find that x comma y, that if we substitute it into both equations, it's going to be true. So let's look at the beautiful thing about this setup. We already know that y is equal to 1. We have that definitive number. We know for a fact that y is equal to 1, since the equation is y equals 1. So what we're going to be able to do is substitute in the value of 1 into the other equation where we see y. We're going to replace the y with 1. So we have negative 4x plus 2y is equal to 2, but we know that y is equal to 1. We can simplify. 2 times 1 is positive 2. And we drop everything else down that we aren't working with yet. Well, we want to get that negative 4x all by itself. We want to eventually get the x by itself, but we need to isolate the term that has our variable. So we're going to subtract 2 on both sides. Therefore, we end up with negative 4x is equal to 0. And we need to actually write 0 because we need to know the number that it's equal to. 2 minus 2 is 0. We cannot leave it blank. We have to write 0. And now we have negative 4 times x. So we need to divide both sides by negative 4. And we get that x is equal to 0. But now we need to check. We always want to check our work. And that's the beautiful thing here is we can always check our work. It's whether or not we're going to be lazy and not do it, or if we're going to take pride in our work and make sure that we're checking. Because we will always know if we are right or wrong, because we can check. So please take the extra minute or so, double check your work. So again, we already know that y is equal to 1, so there's nothing to check in that top equation. But we can go to that bottom equation. Negative 4x plus 2y is equal to 2. We can replace the x and the y letters, the variables, with what they're equal to. We know that x is equal to 0, and we know that y is equal to 1. So we can simplify now. Negative 4 times 0, well, that's 0. 2 times 1 is 2, and 0 plus 2 is 2. So therefore, our final answer is going to be our x comma y. The x value is 0, the y value is 1. So therefore, the solution to this system is 0, 1. Awesome. Let's go through another problem. Problem number 7 looks like this. The system is y equals 3x plus 7, and 2x plus 2y is equal to negative 10. So here's the beautiful thing about this system, is we know what y is equal to. We know that y is equal to 3x plus 7. We may not know the value of 3x plus 7, but we know that we don't need the y because we know it's equal to 3x plus 7. So in the other equation, just like we did before, when we had a definitive number, we're going to replace the y with 3x plus 7. Let's actually do this in green because the yellow was a little bit difficult to see. We know y is 3x plus 7. And in the other equation, we're going to substitute or replace the y with 3x plus 7. We have 2x plus 2 times y, which we know is equal to 3x plus 7 because there's an equal sign. All right, we look inside our parentheses. We cannot combine any like terms with 3x plus 7. So now we look just outside, and we're going to use the distributive property. So 2 times 3x is positive 6x. 2 times 7 is positive 14. That's equal to negative 10. We can combine some like terms here. 2x plus 6x becomes 8x. And they're on the same side of the equal sign, so we're able to combine them. Plus 14 is equal to negative 10. We want to get that x all by itself, so the first thing we're going to have to do is move that positive 14 to the other side by subtracting 14. Therefore, we get 8x is equal to negative 10 minus 14. If you lost $10 and you lose 14 more dollars, well, you lost 24. And now we're going to divide both sides by 8 to get that x all by itself, and x is going to be equal to 3. So we're halfway there. We now need to make sure that we can get that y value. We have the x value, which is great, but we need to find the y value. We know that y is equal to 3x plus 7. So we're going to replace now the x with what we know. We know it's equal to 3 plus 7. Oh, no, it's negative 3. Goodness golly. Good catch, Mr. Q. It's going to be negative 3 because negative 24 divided by positive 8 is negative 3. I'm so sorry. It's been a week, but we're going to push on through, and we all make errors. That's totally okay so long as we correct them, right? All right, cool. So 3 times negative 3 is negative 9 plus 7. Y is going to be equal to negative 2. We can check this by plugging into both equations, our x and our y. Make sure you're staying organized. We have y is equal to 3x plus 7. The y value is negative 2 is equal to 3 times our x value, which is negative 3, plus 7. And we do end up getting negative 2 is equal to negative 2. Now we need to check our other equation. That was 2x plus 2y is equal to negative 10. Our x value is negative 3 plus, that should be in a different color, not a text box. There we go. Plus 2 times the y value, which is negative 2, is equal to negative 10. When we do this, we do indeed get negative 10 is equal to negative 10, which is great. We have to put our answer in parentheses. Remember, it's always our x, comma, y. So it's our x and our y. The x value was negative 3. The y value was negative 2. And that's going to be our final answer. Negative 3, comma, negative 2. All right, we got one more example to go through. Here we go. Let's talk about problem number 19. Problem number 19 is a little bit different, but I really like this setup. It's going to be a setup that when you see it, you'll be like, yes, because in that top equation, y is equal to 2x minus 8. So just like our previous example, we know what y is equal to. We know it's equal to 2x minus 8. So what we can do is replace or substitute the variable y for 2x minus 8 in the other equation. And what you're going to notice is that when we do that, we're actually on the opposite side of the equal sign. Because the bottom equation is y equals negative 3x plus 12. But we already know that y is equal to 2x minus 8. So as we substitute, this is when we get a fairly straightforward setup. We need to get our x's to one side, non-x's or constants to the other. So we always look at if we can simplify any side individually before we start to move some things over. On the left, we have 2x minus 8. Those are not like terms. I can't simplify anything. On the right, we have negative 3x plus 12. Those also are not like terms, so we can't simplify anything. We want to move our variable first. And remember that Q-tip is identify the bigger coefficient. We have 2x and negative 3x. 2 is bigger, so that's going to stay. In order for us to do that, we're going to add 3x on both sides. Notice where I'm placing that plus 3x. I'm putting it under the other term that has the x where I want to show the addition. Well, 2x plus 3x is 5x, and we drop everything else down. Now that we have our x's on our left, we have to get our constants or our non-variable over on the right-hand side. We currently have negative 8 or subtracting 8 on the left, so we have to add 8 on both sides to undo it. When we do that, we get 5x is equal to 20. And to get x all by itself, we have to divide by 5. Therefore, x is equal to 4, which is great. So now we're going to go back into one of our equations and substitute in the x value that we now found to find the y value. Well, looking at that top equation, we have y equals 2x minus 8. And we know that x is going to be equal to 4. We can simplify 2 times 4. That gives us 8. And now we can do 8 minus 8, which is 0. So we have so far an x value of 4 and a y value of 0. Now we need to make sure and check our work. So let's go and check that work. Here we go. We're going to go into both equations, but one at a time. Y is equal to 2x minus 8. The y value we found was 0. That's equal to 2 times our x value, which is 4, minus 8. When we check it, we do indeed get 0 equals 0, so that's true. It works for the first equation. Now let's go over and verify it works for that second equation. Y is equal to negative 3x plus 12. Our y value is 0. That's equal to negative 3 times our x value, which is 4, plus 12. As we simplify, negative 3 times 4 is negative 12. And negative 12 plus 12 is indeed 0. So our final answer, again, it's always our x, comma, our y. Our x is 4, and our y is 0. So our final answer is 4, 0. That's the solution to our system. Fantastic job with this, kiddos. Keep up the great work. Please don't hesitate to let us know if you have any questions, and I'll talk to you soon.